Hello guys, welcome to Backbencher Studies channel. In the last video, we have discussed how we can derive the expression for rise time. We also saw what is rise time in the graph. So in this lecture, we are going to learn about the peak time of this second order response. So we already learned the definition of this peak time, which is the time required from the initial stage to reach the maximum value of this output. So that is what we can depict as peak time. So let us see what is peak time according to graph. So here we have the time axis over here, and we have the amplitude axis, which is C of t axis, the amplitude of C of t axis over here. So so this is the steady state input, steady state value, which is the input we are giving to the second order system, which is nothing but u of t. So the system wants to reach this steady state value in an oscillatory manner. So it will first starts from 0 and reaches to 1, and then it will continuously oscillate about this position. We saw that response, the graph of this response in the last lecture as seen. So this is the maximum value, and if you expand these oscillations about this steady state value, then it is kind of like exponentially decaying. So this one will be the maximum value we can achieve. So this, from starting to this up to achieving this value, what will be the time, that we call it as peak time. So this is what we have peak time, and this is what the steady state value. So if we observe, so to derive this, how we can do that? So let us see. So if we observe that at maximum value, we have the slope of this curve as 0. That is very basic mathematics equation we can derive from maximum and minimum condition. A function f of x will be maximum when its slope is 0. So by using this basic maximum and minimum condition, we can derive what is called a peak time. So let us derive what is we call as peak time. So here we have the output of this second order system, which we derived in the last class. So we need to equate the slope of this curve to equal to 0, because we have the slope of the function equal to 0 at the maximum value. So the time at which the slope will become 0 with for this function is what we call as peak time over here. So let us derive. So if we differentiate this signal with respect to time like this, so this one will vanish as differentiation of constant will be 0. And if we differentiate this function of time, we can have two functions over here. One one we can assume this whole function as u, and if we assume this whole function as v, then this is kind of differentiation of uv over here. So we have the differentiation of uv as u v dash plus u dash v. So if we do that, so let us first take this u, and if we differentiate this sine omega dt plus theta with respect to time, we have cos omega dt plus theta, and if we internal differentiate this omega dt, we have this omega d over here. And if we leave this alone, and if we now differentiate this thing, then exponential differentiation would result into an exponent only. So d by dx of e power x is e power x. So but if we differentiate internally this minus del omega nt, then we have minus del omega n over here. So if we, so this differentiation is not 0 at all the cases, but it is 0 only at this particular time value of t equal to tp. So let's substitute t equal to tp in this equation, then we can get the value of tp as shown here. So if we substitute this and equate this to 0, we can kind of, if we multiply this thing with 0, then this one will get vanished, and all we have left is omega dt cos omega dt tp plus theta minus del omega and sine of omega dt tp plus theta over here is equal to 0. So substituting the value of omega n in this equation, omega d in this equation, omega n into root of 1 minus delta square cos of omega dt p plus theta minus del of sine of omega dt plus theta. And if we kind of take this omega n common and we cancel that, then we are left with this 1 minus delta square, this equation over here. So in the last class, we have discussed what is this tan theta over here. Tan theta, based on this tan theta, we can write this as sine of theta over here. And this delta is can be written as cos of theta. So if we substitute this in this following equation, we are left with this equation. So this is kind of sin A cos B minus cos A sin B over here. So if we substitute this trigonometric equation as per this equation over here, we are left with this sine of theta minus omega dtp minus theta is equal to 0. So this theta will get cancels out, and this omega minus omega dtp will become, will left over in this sine term. So if we equate this to 0, that is, so, and it will, if we are seeing this graph, if we see this graph, so this graph over here, it, the slope is becoming 0 at multiple number of times, because if we extend this sinusoidal will have the maximum value over here. So here also the slope will become 0. So here we have n number of values for which the slope becomes 0. So that is being shown over here. So sine of theta is equal to 0 means theta can be equal to n pi, but we are seeing only for the first time. So what will be the value of this slope? So for the first time, how, when will be the slope becomes 0, that we call it as the peak time over here. So we substitute n equal to 1 over here. Thereby we are getting the value of peak time as pi by omega d from this equation which is left. So this is how we can derive the value of peak time for the second order system. That's all for today, guys. In the next lecture we will be learning how we can derive the peak time and settling time. So thank you, guys. Thank you for your amazing session. If you are new to our channel, please do subscribe to our channel.